Hello guys, this is NP Chan. Welcome to my mathematics class. Let's see today's topic, laws of algebra of sets. Today's very important topic. This topic I have taken from grade 11. Alright. Well, let's see how to prove. I have taken three laws: distributive laws, De Morgan's laws, and difference laws. And here's which statement I have taken. What do you mean by the distributive laws? Distributive laws mean let A, B, and C be the subsets of universal set U. Then A union B intersection C is equal to A union B intersection A union C. Okay. A intersection of B union C is equal to A intersection B union A intersection C. De Morgan's law, A and B are the subsets of universal set U. Then complement of A union B is equal to A complement intersection B complement. Complement of intersection B is equal to A complement union B complement. This is the statement of the De Morgan's law. And difference laws here, A minus B union C is equal to A minus B intersection A minus C. A minus B intersection C is equal to A minus B union A minus C. Today I will tell you how to prove these three laws, right? Okay, so let's start. Before starting to prove these laws, we have to know the definitions of union, intersection, difference. All right. So what is the symbolical definition of A union B? Alright, so we need only symbolical definition. Okay, if we know these definitions, we can do very easily. See, listen to me here. X says that X represents the general element of a union B. Either X belongs to A or X belongs to B. This is the symbolical definition, or you can say in set builder form. This is the definition of A union B. And from here we can write, if you get this one, A union B, you can write down, X belongs to A or X belongs to B, you can write down. One is this one, and second, if X does not belongs to A union B, so it's sure, if any element is not in A union B, then that element is not definitely in A and in B. Alright. So in case of if X does not belong to A union B, you can write down implies X does not belongs to A and X does not belongs to B. Alright. And A intersection B, or intersection B, X says that X belongs to A and X belongs to B. This is the definition of intersection. Alright. In intersection, some properties we discuss. If we have X belongs to intersection B, you can write down X belongs to A and X belongs to B. Alright, here and In X is the element in both A and B. And so if X does not belongs to A intersection B, then we are not sure that element is not in both. We write X does not belong to A or X does not belongs to B. In case of does not belong to A intersection B, then that implies X does not belongs to A or X does not belongs to B. If we know these properties, definitions and properties of union as well as intersection, we can do very easily proofs of these questions. Alright, so I'm going to tell you the distributive laws, how to prove. It's very easy. Just I'm going to use definition. So let's start. Here we go. One first. A union B intersection C. So firstly, defining A union B. So whole you can suppose as a B. Or we can write down X such that X belongs to A, or and here X belongs to B intersection C, we can write down, right? So just I will use definition of A union B. So if we suppose this is a and this one is a whole B, then we can write down X such that X belongs to A or X belongs to B. I have just used the definition of A union B. So now here see x says that x belongs to A, or here x belongs to B intersection C. Let's try to apply the okay this. If we have okay x belongs to B intersection C, here small bracket you will write down here x belongs to B, and we can write down. This is the definition from the definition of intersection. X belongs to B and x belongs to C. Okay, so I think now clear. Now we write down, okay, now we have to use distributive property, right, of simple. So see, x belongs to A, or this and this or this and this or this we have to take, right? Okay, like this way, and this one you can take. X belongs to A or x belongs to B. This is called the distributive property, and x belongs to A or x belongs to C. Okay, so is equal to x says that x belongs to A union B, and x belongs to A union C, we can write down, right? Now see, x belongs to this whole. If you take A, this whole is B, then B can, x belongs to A and x belongs to B. Mean definition of intersection. Using the definition of intersection, we can write down A union B intersection A union C. So therefore, A union B intersection C is equal to A union B intersection A union C. So easy. Alright, the first part, distributive laws of, okay, first part I have done, right? So second part you can do very easily if you use, okay, the same method. Firstly you need to use the definition of intersection, and then here you can use, okay, definition of union, and then distribute, and thereafter definitely you gonna get the right hand side of this second part, right? So okay, so I don't think you will have any problem, right? If you have problem, you have a comment box, you can write down, definitely I'll give the reply of your question. Okay, now let's move into the second, De Morgan's law. I'm going to tell you here also. I will tell you the one second. I will leave for you for practice. Okay, here also I will tell you one, and then you can do, right? So very easy, not so difficult, but very important from the examination point of view, right? NEB examination point of view. NEB means, okay, National Examination Board exam, right? Okay. Second, okay, De Morgan's law, second part. I'm going to, okay, first here. Sometimes, okay, you may get question like this way: state and prove. At the time, you have to know the statement of De Morgan's law and the statement of distributive laws. Okay, statement of difference laws. And why I have chosen these questions for today's video, because frequently we find in exam, okay, right? That's why I've taken these questions, and very important in sets, right? Okay, so second first, okay, you will get, okay, in exam, okay, state and prove De Morgan's laws. So that's why, okay, you need to memorize also statement. Okay, so this is the statement of the De Morgan's laws, right? I'm going to prove the first part, okay. Here, okay, A union B, complement of A union B, okay. So let's suppose, okay, x be an element of this one. X is the x says that x belongs to A union B, complement of A union B. X says that x belongs to A union B, complement of A union B. X is the element of this, okay? X is the element of set complement of A union B. Now, there is a one property in complement. If x belongs to a complement, so see, if x belongs to a complement, implies x does not belongs to A. So definitely it's true, because complement means element of U that does not belong to A, right? That is called the A complement set of, right? A complement means set of elements of U which are not in A. So if, okay, if x belongs to a complement, definitely x does not belongs to A. This is the property of complement. Now, okay, so here I'm gonna use this property. X says that x does not belongs to A union B. Now I'm going to use the property of X does not belongs to A union B. So it's a common thing. If any element is not in union, is not in A union B, definitely X is not the element of component set of A union B. Component sets means A and B. X is not definitely the element of A and B. Okay, so here we can write down like this way. X says that X does not belongs to A and X does not, or if you write here or, that's the wrong. Okay, if any element does not belong to A union B, definitely element is not in A as well as in B. X does not belongs to V, right? B. Sorry, pronunciation here B, not V. Okay, so as I just now I told you, if X belongs to A, then X does not belongs to a complement. Here, if X belongs to A, if X does not belongs to A, then X definitely belongs to its complement. And here X belongs to B complement. I think you understood. Now we have got the definition of A intersection B. So here we can write down, okay, complement of A intersection complement of B. So therefore we can write down, okay, A union B whole complement is equal to A complement intersection B complement. Alright, so I also think you have a problem. Now I'm going to tell you another alternative also. Alternative also of this proof. So see, A union B whole complement, we can write down like this way also. X says that X belongs to A and X does not belongs to A union. Okay, A union B. Okay, so X belongs to U and X does not belongs to A union B. If you think from where I have written this one, so I have used just definition of the complement. What is the definition of a complement? X says that X is the element of a complement. X belongs to U and X does not belongs to A. This is the definition of a complement. So same thing I have used here. X belongs to U and X does not belongs to A union B. U is a universal set. Okay. So now here X says that X belongs to U and here bracket I'm using small bracket. X does not belongs to A and X does not belongs to B. Now you need to use a distributive property. This and then again, okay, this you need to take, and is equal to, because this is also true in case of the sets, X belongs to U and X does not belongs to A, and X belongs to U and X does not belongs to B. So easy, not so difficult, so no panic, it's very easy. X says that X belongs to a complement. This is the definition of a complement. So you can write on a complement and X belongs to B complement, and finally you will get A complement intersection B complement. Alright, so therefore, okay, left hand side is equal to right hand side. I have told you the both methods, so you can use anyone, both are absolutely correct. Okay, there is no doubt in both methods. Alright, so as you wish you may use anyone, right? But very important. And the second one also you can do in this way, right? Any one method you can apply to prove the second part of the second. Alright, De Morgan's law. So very important. Let's move into the difference laws. So I'm going to prove here also the first part in difference laws. So sometimes, okay, you may get question, state and prove difference laws. You have to memorize, okay, this statement, right? Okay. First. On the left hand side I have, okay, A minus B union C is equal to, now here I will use the definition of difference, okay. What is the definition of a difference? Let's see. A minus B is equal to X such that X belongs to A and X does not belongs to B. Exactly the same definition I'm gonna use here, right? So okay, so this definition, your A and this one is a will like this, but you can think X says that X belongs to A and X does not belongs to B union C. Is equal to here X says that X belongs to A, and now you need to open here. So just now I told you X does not belongs to B and X does not belongs to C. Okay, so here now you need to use the distributive. X says that X belongs to A and X does not belongs to B. Okay, here no space, that's why I'm writing here X belongs to A and X does not belongs to C. Okay, is equal to X such that here X belongs to A minus B. This is the definition of difference. And here X belongs to A minus C. Okay, now X belongs to A and X belongs to B means definition of intersection. Now you can write down the A minus B. This is your A intersection A minus C. So alright, be approved. Therefore, okay, A minus B union C is equal to A minus B intersection A minus C. So I also think you have enough problem. So everything is clear in this question, right? Okay, now let me tell you the second part also, because here is intersection and that's why. Okay, the second part of this question. So let's see, very easy, not so difficult. Okay, A minus left hand side of the second part of the question number third I have written here is equal to here X says that X belongs to A and definition of difference does not belong to B intersection C, right? So is equal to X says that X belongs to A and now you need to use a small bracket. X does not belong to A. Here, okay, students do mistake, okay, at this point. X does not belongs to B intersection C. Listen to me. If X belongs to B intersection C, then we can write down, okay, X belongs to B and X belongs to C. But here we have, okay, case of does not. X does not belongs to B intersection C. This means, okay, we can write down here X does not belongs to your B or not, and here I'm not right. If you write here and this is wrong, okay, you're okay. X, okay, may or may not be, alright, may not be in B or C, right? May be in B or may in C, right? But not in B. So X does not belongs to B or X does not belongs to C. This is the correct statement for this, right? If you write at and, if you write, okay, X does not belongs to B and X does not belongs to C, that's not a bit correct, okay, right? If, okay, suppose, okay, X is the one belongs to A and one, okay, does not belongs to B intersection C. So one may be B, okay, one may not belongs to C. Even then, okay, one does not belongs to B intersection C, alright? So that's why here or you need to write down. It requires or. Okay, now let's use, okay, distributive. So only for this I have done these questions for you. X says that X belongs to A and X does not belongs to B, or X belongs to A and X does not belongs to C. Here A minus B, A minus C. Definition of difference. X says that X belongs to A minus B or X belongs to A minus C. I have just used the definition of difference. Now, okay, A, if we suppose, okay, this is A, this one is B, then A or B. Definition of union. A minus B union A minus C. Easily you can do, right? Therefore, A minus B intersection C is equal to A minus B union A minus C. So very important questions, but not so difficult. If you know the definitions of union B, A intersection B, and A minus B, a complement, and their properties, then very easily you can handle these questions. Alright. So I also think now you have a problem. You understood all these three laws. Okay. Thank you very much for watching. Bye bye.